This is lesson 8.4, trigonometry, starting on page 573. Express each ratio as a fraction and as a decimal to the nearest hundred. Number one, the sine of A. So we need to remember SOHCAHTOA. Sine is opposite over hypotenuse. So the sine of A, 16 would be opposite. The hypotenuse across from 90 is 20. This would simplify. If we divide them both by 4, we get 4/5. And if we write that as a decimal, that would be equal to 0.80. Number 3, the cosine of A. Cosine is adjacent over hypotenuse. So the adjacent leg over the hypotenuse from angle A. So from angle A, the leg that is next to the angle is 12. And our hypotenuse is still 20. And we can simplify that, divide them both by 4, and we get 3/5, which is equal to 0.60. And for number 5, the cosine of C. So now we want adjacent over hypotenuse starting from angle C. So for angle C, the adjacent leg, the leg next to the angle, is 16, and our hypotenuse is still 20, which this simplifies to 4/5, which is equal to 0.80. Number 7, use a special right triangle to express the sine of 60 as a fraction and as a decimal to the nearest hundredth. So the first thing that we should do is draw a 30, 60, 90 triangle. And we know that the ratio of the short leg to the long leg is 1 to square root of 3. So 1 times the square root of 3 is the long leg, and 1 times 2 is the hypotenuse. So from this, we can find the sine of 60. So the sine of 60 would be opposite, which is the square root of 3, over hypotenuse, across from the right angle, is 2. So as a fraction, we have the square root of 3 over 2. And using a calculator to the nearest hundredth, that is 0.87. For number 9, we want to find x and round to the nearest hundredth. So the angle that we are given is 61 degrees. And we're trying to find x, which is the hypotenuse, and we're also given the side opposite from 61. So the only trig function that uses opposite and hypotenuse both would be sine from SOHCAHTOA. Sine is opposite over hypotenuse, so we would set up our proportion. So the sine of our angle, sine of 61, let's put that over 1, is equal to opposite over hypotenuse. So that would be 24 over x. From here we'd cross multiply, so we take x times the sine of 61 is equal to 1 times 24. And then we have one last step. We need to divide both sides by the sine of 61 so that we get x by itself. So, using a calculator, let's take 24 divided by the sine of 61, and that is approximately 27.44. And number 11, David is building a bike ramp. He wants the angle that the ramp makes with the ground to be 20 degrees. If the board he wants to use for his ramp is 3.5 feet long, about how tall will the ramp need to be at the highest point? So we have our 20 degree angle, and we have 3.5, which is the hypotenuse across from the right angle, and we want to find how tall it will be. So we want to find this side right here. So we'll call that x. So x happens to be opposite from our angle. So we have the opposite and the hypotenuse. So the trig function that we need to use is sine from SOHCAHTOA, opposite over hypotenuse. So the sine of our angle, 20, put that over 1, is equal to our opposite side over our hypotenuse. So to solve for x, we cross multiply. X times 1 is equal to 3.5 times the sine of 20. So 3.5 times the sine of 20 is about 1.2 feet. For number 13, use a calculator to find the measure of angle z to the nearest hundredth. So for angle z, the information that we have here is we have the side next to the angle, so that is the adjacent, and we're also given the hypotenuse. So from SOHCAHTOA, the only trig function that uses both adjacent and hypotenuse is cosine. So the cosine of angle z is equal to adjacent over hypotenuse. So then to find our angle, z will be equal to the inverse cosine of 10 divided by 14, which is approximately 44.4 degrees. Number 15, solve the right triangle. Round side measures to the nearest tenth and angle measures to the nearest degree. So first we need to find our missing side using the Pythagorean theorem. So let's call that x. So x squared plus 6 squared is equal to 9 squared. And if we simplify, we would get 36 and 81. And if we subtract, x squared is equal to 45. And if we take the square root, it says round to the nearest tenth, we get 6.7. So x is 6.7. Actually, we want to call that what it is. That is side RS. Side RS is approximately 6.7. Now, we also want to find our missing angle measures. So we'll start with R. And I don't want to use this approximation. I want to use these exact values that I already know. So opposite from R is 6, and the hypotenuse is 9. So the trig function that uses opposite and hypotenuse would be sine. So we would set this up as the sine of R is equal to our opposite side over our hypotenuse. So R is equal to the inverse sine of 6 over 9, 6 divided by 9, which is approximately 42 degrees. And now that we know that, we can find the measure of angle T. So the measure of angle T is equal to 90 minus 42, since our acute angles must be complementary in a right triangle, and that would be 48 degrees. So we have found measure of angle R, measure of angle T, and side RS. For number 17, we want to find the sine, cosine, and tangent of J, as well as the sine, cosine, and tangent of L. Express each ratio as a fraction and as a decimal to the nearest hundredth. So we'll start with finding the sine, cosine, and tangent of J. refer to SOHCAHTOA. So for the sine of j, we want opposite over hypotenuse. So from j, opposite is 56, and our hypotenuse is 65. So 56 over 65 is approximately 0.86. Then the cosine of j. So we want the adjacent leg to j, so that would be 33. Cosine is adjacent over hypotenuse. So our hypotenuse is still 65, so 33 over 65 is approximately 0.51. And then the tangent of j. So tangent, excuse me, the tangent of j, tangent is opposite over adjacent. So from j, our opposite side is 56, and our adjacent side is 33. And 56 over 33 gives us approximately 1.7. Next, we want to find the sine, cosine, and tangent of our other acute angle, which is L. So now 33 is opposite, hypotenuse is still 65, and our adjacent leg is 56. So we want the sine, cosine, and tangent of L. Sine is opposite over hypotenuse, so that would be 33 over 65, which we know from before is 0.51. And the cosine of L, cosine is adjacent over hypotenuse, so that would be 56 over 65, which we found earlier, 0.86. And the tangent of L, so opposite over adjacent, so that would be the reciprocal of the tangent of j. So opposite over adjacent would be 33 over 56. And 33 over 56 is approximately 0.59. For number 19, we're doing the same thing. So we're taking the sine, cosine, and tangent of j and of L. So I'll skip that one. Let's do one with radicals in it. So the sine, cosine, and tangent of j first. So opposite is 2 squared to 6. My hypotenuse is 4 squared to 2. And my adjacent leg is 2 squared to 2. So sine is opposite over hypotenuse. So 2 squared to 6 over 4 squared to 2. And 2 and 4 cancel, so that would be 1 over 2. And the square root of 2 and the square root of 6 reduce, so 2 goes into 6 3 times. So I'm just left with the square root of 3 over 2, which is approximately 0.87. Now for the cosine of j, cosine is adjacent over hypotenuse, so that would be 2 square root of 2 over 4 square root of 2. So the square root of 2 and square root of 2 cancel, and 2 over 4 simplifies to 1/2, which is 0.5. And then the tangent, which is opposite over adjacent, so that would be 2 square root of 6 over 2 square root of 2. So the 2's cancel, and the square root of 2 goes into the square root of 6, so that would be the square root of 3, and the square root of 3 is approximately 1.73. And we also want to find the sine, cosine, and tangent of L. So for L, now my opposite is 2 square root of 2. Hypotenuse is the same, and my adjacent is 2 square root of 6. So the sine of J will be the cosine of L. So the cosine of L will be the same answers we have here. Square root of 3 over 2. And the cosine of J will be the sine of L. So the cosine of J is 1/2. And the tangent of L will be the reciprocal of the tangent of J. So the reciprocal of square root of 3 would be 1 over the square root of 3, which we rationalize. So we get square root of 3 over 3, which is approximately 0.58. For 23 through 27, use a special right triangle to express each trigonometric ratio as a fraction and as a decimal to the nearest hundredth. So we have 30 degrees and 60 degrees, so let's make our 30, 60, 90 triangle. And our short leg, let's just call that 1, therefore the long leg would be 1 times the square root of 3, and our hypotenuse is 1 times 2. So the cosine of 30, cosine from SOHCAHTOA, cosine is adjacent over hypotenuse. So adjacent, the leg next to angle 30 is the square root of 3. Over our hypotenuse, opposite from the right angle, is 2. So we get the square root of 3 over 2, which is approximately 0.87. Then we want the sine of 30. So the sine from SOHCAHTOA is opposite over hypotenuse. So opposite from 30 is 1, and the hypotenuse is 2. So that would just be 0.5. And then the cosine of 60. For the cosine of 60, cosine is adjacent over hypotenuse, so from 60 degrees, the leg next to this angle would be 1 over our hypotenuse, which is still 2. To find x on number 29, we want to look from this angle, 49, and we are given the side opposite from that, and we're trying to find the leg adjacent to that. So from SOHCAHTOA, the only ratio that uses both opposite and adjacent is tangent. SOHCAHTOA, opposite over adjacent. So we would set up our proportion as the tangent of 49, put that over 1, is equal to our opposite, which is 33, over our adjacent, which is x. So we cross multiply, we take x times the tangent of 49 and set that equal to 33 times 1. To solve for x, we need to divide by the tangent of 49. So 33 divided by the tangent of 49 is approximately 28.7 to the nearest tenth. On number 31, we are given the angle of 63 degrees. In relationship to this angle, the side that we are given is next to the angle, so that is adjacent. And we're trying to find this side, and this side is opposite from the right angle, so that's the hypotenuse. From SOHCAHTOA, we would be using the cosine to solve for our variable, because we have adjacent and hypotenuse. So we would set this up as the cosine of 63, put that over 1, and set it equal to the adjacent over the hypotenuse. So now we can cross multiply, so we'll take x times cosine of 63, set that equal to 1 times 15 square root of 3, and then to solve for x we have to divide by the cosine of 63 to get that to cancel. So we divide the other side by the cosine of 63. So we need to take 15 times the square root of 3 divided by cosine of 63. And that would be 57.2 to the nearest tenth. On number 33, our angle is 38 degrees. In relationship to this angle, we are looking for this side, which is opposite from the angle. We're given this side, which is opposite from the right angle, so that is the hypotenuse. And from SOHCAHTOA, we would have SO, which is sine, which is opposite over hypotenuse. So the sine of 38, put that over 1, is equal to opposite over hypotenuse. From here we cross multiply, so we take x times 1, and then we would just take, on a calculator, 20 square root of 2, so 20 times the square root of 2, and multiply that by sine of 38. And that would round to 17.4. For number 35, the angle of ascent of the first hill of a roller coaster is 55 degrees. If the length of the track from the beginning of the ascent to the highest point is 98 feet, so we are given this side, which is opposite from the right angle, so that's hypotenuse. What is the height of the roller coaster when it reaches the top of the first hill? So we want to figure out how high this roller coaster is. So that would be the side opposite from our angle. We'll just call that x. From SOHCAHTOA, we have hypotenuse and opposite, so that would be SO, which is sine, which is opposite over hypotenuse. So we set it up this way, the sine of 55, and put that over 1, and set that equal to opposite over hypotenuse. From here we just cross multiply. So we would take 1 times x and set that equal to 98 times the sine of 55. So if we type in 98 times the sine of 55, On our calculator, we should get 80 feet. Number 37, use a calculator to find the measure of angle T to the nearest tenth. So we're looking for angle T. So from this angle, the sides that we are given is the side next to the angle, so adjacent, and the side opposite from the right angle, so hypotenuse. And from SOHCAHTOA, the ratio that we'd be using is cosine, which is adjacent over hypotenuse. So the cosine of angle T is equal to adjacent over hypotenuse. Put cosine of T over 1, and then cross, whoops, I'm sorry. I had a momentary lapse of reason there, sorry. So the cosine of T is equal to 11 over 23. We want to find the measure of the angle. So the angle will be equal to the inverse cosine of 11 divided by 23. And to the nearest tenth, we would have 61.4 degrees. For 39, angle T is here. We are given the side opposite from our angle, and we're also given the hypotenuse. From SOHCAHTOA, this would be SO, opposite over hypotenuse. So the sine of T is equal to 21 over 44. Therefore, the measure of angle T will be equal to the inverse sine of 21 divided by 44. And that is approximately 28.5 degrees. And for 41, angle T is here. We are given the side opposite from our angle, and we're also given the side adjacent to the angle. From SOHCAHTOA, opposite over adjacent would be TOA. So the tangent of our angle is equal to opposite over adjacent. And the square root of 3 cancels, so I'm going to go ahead and simplify. So the measure of angle T will be equal to the inverse tangent of 4 divided by 10, which is approximately 21.8 degrees. For 43, we want to solve the right triangle, round side measures to the nearest tenth, and angle measures to the nearest degree. So first, we would find the measure of angle W, which is 90 minus 57, our other acute angle, which would be equal to 33 degrees. And we also want to find XW, so let's call that X, and XZ, which we will call Y. So we'll solve for X and our angle. We have X is the opposite side and 18 is the hypotenuse. So we'd use O and H, so that's SO from SOHCAHTOA. So then we have the sine of our angle, 57, put that over 1, set up our proportion, so it's opposite over hypotenuse, so X over 18, then we cross multiply. So 1 times X would be X is equal to, and then 18 times the sine of 57. And we would type that in. So X is WX, which is 15.1. Okay, and we also need to find y, or xz. So I'm going to get rid of this information here just so I can focus on what I'm looking for. So I have this angle, and I'm given this side, which is the hypotenuse, and now I'm looking for this side, which is adjacent to the angle. So that would be ka from SOHCAHTOA, adjacent over hypotenuse, so we would take the cosine of our angle, put that over 1, and set it equal to our adjacent, which is y, over the hypotenuse, which is 18. And once again, to solve for y, we would cross multiply. So y is equal to 18 times the cosine of 57. And y represents xz. So xz is approximately 9.8. So we've solved this right triangle, we found the missing angle, and our two missing side lengths.